In this video, we will be looking at our first control flow structure called selection statement or conditional statement. Up to now, we have written program using sequencing, that is, executing all the statements of a program in sequence from top to bottom. Sequencing allows us to write only very simple and basic program. Today we explore conditional statement. Conditional statement perform different computation or action depending on whether a Boolean condition evaluates to true or false. Let's consider a simplified everyday problem that a person may face when a person is going out of its home. When going out of its home, the person may execute the following command. Take phone, take wallet, take keys, take sunglasses, take umbrella. You may notice that taking sunglasses and an umbrella at the same time may not be the most logical action. In order to write useful program, we almost always need the ability to check condition and change the behavior of the program accordingly. It is sometimes called branching. In our example, if it is sunny, the person takes the sunglasses, otherwise it leaves them at home. Similarly, if it is rainy, the person takes the umbrella, otherwise he leaves it at home. Ideally, we should be able to have mutually exclusive branches. For example, we may want to decide that in our simplified model of the British weather, if it is rainy, it cannot be sunny, and therefore a person cannot take sunglasses at the same time as an umbrella. Finally, if it is neither rainy or sunny, we do nothing. It is represented by the middle branch in our diagram. The program now has two branches and a shortcut to skip the two branches. In a programming language, conditional statement, also known as selection structure, give us this ability. The simplest form of conditional statement is the if statement. It is represented by the schema on the left-hand side. If the condition is true, the program executes statements A1 to AN and then statements X and Y. If the condition is false, the program bypasses the statements A1 to AN and only executes statement X and Y. The Python syntax is shown on the right-hand side and the keyword is if. The Boolean expression after the if keyword is called the condition. If the condition evaluates to true, then the indented statement gets executed. If not, nothing happens and only the statements X and Y are executed. The indented statement composes the body of the if structure. Statements like this are called compound statements. There are no limits on the number of statements that can appear in the body, but there must be at least one. Considering the schema shown on the left-hand side, we check if it is sunny or not, and depending on the evaluation of the condition, the person takes the sunglasses or not. This can be written in Python like this. For clarity, we do not show the code to input a value for the variable weather. The condition in the if structure evaluates if the variable weather is equal to string sunny. If that's the case, then print the take sunglasses, otherwise skip the statement and move to the next instruction. If weather is equal to rainy, print take umbrella, otherwise ignore that statement and move to the next one. In our previous model, it might have been possible to take both, but in the model shown on the left, taking an umbrella and taking sunglasses are mutually exclusive, meaning you cannot take both. At most, one of the two statements in the branches will be executed. In some cases, none of them are executed, for example, if the weather is equal to foggy. In Python, we use the if-elif structure, where elif is an abbreviation for else if. each condition is checked in order. If the first condition, whether equal Sunny, is false, the next condition is checked, and so on. If one of them is true, the corresponding branch executes on the statement's end. Even if more than one condition is true, only the first branch where the condition is evaluated to true will execute, not the other one. So what is the difference between the simple if and if-elif statement? On the left-hand side, in some cases where the weather is sunny and the temperature is cold, we will be taking both our coat and our sunglasses. When considering the code on the right-hand side, this is not possible. If it is sunny, we take our sunglasses, but not a coat, even if it is cold. At most, one of the branches can be executed. In conclusion, you must choose your structure carefully. In contrast to the if-elif structure, where none of the branches may be executed, in the model on the right-hand side, exactly one of the two branches will be executed. This is the third form of the if statement. This represents alternative execution, also known as if-else statement, in which there are two possibilities and the condition determine which one gets executed. For example, if you want to check if a student passed a module or not, the condition checked if the mark is greater or equal to 40. If that's the case, the student passed the module, otherwise the student fails the module. The else clause catches all other cases, that is, all marks that are below 40. Note, this is implicit and we don't need to add the Boolean expression to the else clause. Having said that, it is sometimes useful to add what the else clause means in a comment as shown in our code snippet. On line 1, we take the input from the user. Let's assume the user enters a mark of 70. On line 2, we check the condition, which is true. 70 is greater than 40. We execute line 3 and exit the if-else statement. Let's look at a second example. Let's assume that the user enters a mark of 25. The condition becomes false as 25 is not greater than 40. We skip line 3 and go directly to the else statement. And then we execute the compound statement of the else clause, in our case, the line 5. Once done, the program exits the if-else structure. We can combine the if-elif with the else clause. In that case, the else clause must be the last clause of the if-else structure. If condition 1 is true, then execute A and exit the structure. Otherwise, test if condition 2 is true. If that's the case, execute B and exit the structure, and so on. If none of the conditions are true, then execute the statement in the else body. In our example, statement D. Here is a path followed by the program if condition 1 is false and condition 2 is true, regardless of the condition N being true or not. Only statement B is executed. Any if, elif, else structure can be written using only nested if-else structure as shown on the right-hand side. In this case, we need 3 nested conditional statements. The first outer is to test condition 1. The second nested if is in the else clause, and test if condition 2 is true. And finally, the third nested if to check the condition N is again in the else of the second if statement. For a case like this, the use of if, elif, else structure is preferred to a series of nested if-else statements. As you can see from the previous example, there are many ways to code the same program. The challenge is to choose a good one. So, when should we use nested if-else statements? Let's look at the schema on the left-hand side and its implementation on the right-hand side. In particular, focus on the statement B1 and B2. Notice they have been written only once when only using nested if-else statement. Now let's look at a second implementation, only using if and if-else structure. Notice the statement B1 and B2 are written twice, whereas they only appear once in the schema. This is a perfectly working implementation, and it will do the job. The main issue here is the duplication of code. If at a later stage you discover that you made an error in statement B1, you will have to correct this error in two places. This makes your program more difficult to maintain and more error-prone. In summary, you must avoid code duplication. That is, writing exactly the same code multiple times. If you have to copy the same code more than once, ask yourself, is it the best implementation for my problem? Code duplication is a concept I will revisit several times during this course, so do keep that in mind. You have seen how branching works and how a program can execute some statements and skips others, depending on certain conditions being satisfied. Conditional statements allow you to build more interesting and complex programs. Next time, we will be exploring another very powerful control flow structure which allows repetition. Once covered, we will have seen all the necessary programming structure to solve any computable problem.